In this video, we're going to focus on the 21st fundamental problem from chapter 1. We are asked to determine the maximum force P that can be applied to the rod if it is made of a material having a yield stress of 250 megapascals. We are to consider the possibility that a failure occurs in the rod at section A-A, and we are to apply a factor of safety of 2 against yielding. The first thing that you want to do in this type of problem is apply the equation of equilibrium. In this case, we can only apply the sum of x are equal to 0. We see a force P acting on the x component, but it also has an equal and opposite reaction, which is its force Pn. We're going to call it n. So we got P going to the right side, that's positive, minus n equals 0. It means P equals n. Now we calculate the area of the rod. We have a circular cross section, so for that reason we're going to do pi over 4 times the diameter squared. We're given a diameter of 40 millimeters. We want to convert it into meters, so it's going to be 0.040 to the power of 2. We enter this in the calculator and we get 1.26 times 10 to the negative 3 meters squared. Now we calculate the area of the cross section A-A. The cross section is given here below. We have a rectangular cross section, so for that reason we multiply base times height. We have a base of 50 millimeters. We convert it to meters. It's going to be 0.050 meters times 120.120 minus 0.060 meters. We multiply this and get 3 times 10 to the negative 3 meters squared. Now we calculate the allowable yield stress. Sigma allow equals your stress allowed, your yield stress divided by your factor of safety, which is equal to, we're given a yield stress of 250 megapascals, and we divide it by your factor of safety, which is 2. And we get 125 megapascals. We can see that the rod will fail first. Therefore, we take the cross-sectional area of the rod and calculate the max force to be applied. So the equation for this would be your stress allowed equals your P and the area of the rod. You already have your allowable stress, which is 125 megapascals. 125 megapascals, we convert it to pascals by multiplying times 10 to the 6. We equate this to P, your unknown force. And we have the area of the rod, which is 1.26 times 10 to the negative 3 meters squared. We solve for P, and we get 0.157 newtons, or 157.08 kilonewtons. This is our final answer. If you thought the solution was helpful, Don't forget to smash the like button and subscribe.